We have finally reached the end of the notes for 1-3 for AP Statistics, and we are talking about quantitative data and numerical ways to describe a data set. So we have measures of center, we have measures of spread, we have different types of graphs, which you can see here. We have our stem and leaf plots for grams of fat in beef and chicken products from McDonald's again. We've used this example for several things. And on this page, we are going to learn how to do what's called descriptive statistics in our calculators. And what I'm going to do when I get there is I will use the 84 for one of these, and I'll do the inspire for the other. So each one of you can skip, if you have an 84, you can skip the inspire part and vice versa. But everybody, what units will variance and standard deviation have? Now, if you remember that all of this is measuring grams of fat, you need to know that standard deviation will always have units that match the original data set. So standard deviation is going to be measured in grams, and variance will always be whatever the original unit was, but squared. And it has to do with that little chart method that we did on the previous page, in that in order to get to the variance, we had to square everything. Okay, and then we square rooted at the very end to get back to the standard deviation. Now, which distribution will have the higher standard deviation, and why do you think so? If you flip back in the notes, you might remember that we talked about that we had the mean for both of these were higher than the medians, and it had to do with the fact that the mean was not resistant. So in the beef distribution, there was a little bit of a gap. And in the chicken distribution, there's a little bit of a right skew. And both of those impacted the mean. But which one is going to be impacted more when we get to the standard deviation? Well, we'll find out. So you can make your guess right here, and let's see what we have happening. So calculate descriptive statistics. All right, so we're going to start with beef, and I'm going to start with my 84. Now, I had already cleared my memory, so I have nothing in my calculator. If you don't want to clear your memory, you don't have to. But one thing you can do if you have entered data before is if you go to second memory, and there's a thing called clear list. So you could choose option 4, enter. And what that will do is if you had any old data in there, it'll wipe it out. And now you can have all the other stuff that might have been in your calculator. But now when you go to your stat menu and you go to edit, because we need to make new lists, they're all empty. So I'm going to enter all of the beef data in one column. Now, I'm going to enter it in order because that's the way it is here, but you need to know it does not have to be in order to enter it in your calculator. And in fact, so 8 enter, 12 enter, 13 enter, and so on. If it's not in order and you want it in order, the calculator can do that for you, but it really doesn't matter. And 45. You'll notice it says I'm on row 12. Enter, and it's on row 13, but that's where I should be because that was an n size of 12. So the only thing I do notice is it looks like I typed something wrong there. It's supposed to be 23 and then 24 and then 28. So before you do anything, it actually is worthwhile kind of going through and making sure you don't have any mistakes in any typos in your data. Okay, so you have your data. You can quit out of there, but then go back to your stat menu, arrow over to calculate, and you're going to do what's called one variable statistics. Your book will call it descriptive statistics. Your calculator calls it one variable statistics. Is your data in L1? Yes, mine is. If it was in one of the other columns, you have L1, 2, 3, 4, 5, 6. They're in blue. So you could change it. You could say second 4. Is it in L4? No, it was in L1. Don't worry about frequency list right now. Highlight calculate and then press enter. X bar 23.1. Okay, so we have 23.1 We have standard deviation, that is SX 11.3. We'll come back to variance. We have minimum was 8. We have Q1 is 14. Arrow down, median was 22.5. Remember when we did this all by hand? The calculator does it all for us. Isn't that nice? And it's done. That's everything we have. Now, where do we get the variance from? When you do the chart method, the variance comes first, and then you square it to get to, or you square root it to get to standard deviation. You have to do the reverse in this. Now, you could retype that number if you want, but I wouldn't. A, that's not the whole number. It goes on forever. B, it's in the calculator somewhere. Go to variables, VARS. We're doing statistics, so choose menu 5. SX is number 3. Press enter just to confirm it's the right number. Yep, that's it. And then square it. There's your variance, 126.8. So we know that the standard deviation for beef is 11.3 grams. Okay, now I'm going to switch to the Inspire, and we're going to do chicken. All right, for the Inspire, and I hope I don't mess this up. All right, we are going to create a new document. Now, once again, I cleared out my memory. If you had another document going, it's going to ask you if you want to save it or not. Okay, either yes or no, depending on whether you want to save it. You're going to start by adding a list, and you have to name yours. So I'm going to go to the top, and I'm just going to call it CH for chicken. You can generally pick almost anything. Every once in a while, you might pick an abbreviation that is already like a pre-programmed abbreviation, and it'll give you an error message, but otherwise, just go with what you want. Arrow down, but then skip the gray bar. Just skip the gray bar for now. We'll talk about it at some point, but not today. All right, so we're going to enter the chicken data. Same thing. It does not have to be in order when you type it in, but it's going to be because we have it in order. So 10, enter, 17, enter, 17, 19, 19. And I would tell you the same thing I said to the 84s. Double check. Either watch while you're going, or when you're done, go back through and make sure you have everything typed in correctly. And when you end, it says 14. That's good because this was an end size of 13. So when your last enter should drop you down to the 14th row. All right, as you well know, almost everything you need on the Inspire is under a menu. Option 4, we're doing some statistics. We want to do a calculation, option 1. And just like the 84, it's called one variable statistics. Your book calls it descriptive statistics. Your calculator calls it one variable statistics. Now, if you had beef and chicken, if you entered beef in one column and chicken in the next column, you could do all of this in one step. You could say number of lists 2. Well, we only have one column right now. So one column, tab to OK, enter. All right, what column, what do we have? This arrow is a drop-down arrow. So press the right arrow until the drop-down occurs. CH, that's what I called it for chicken. Enter. Just tab through everything. Don't worry about it. Just tab through everything until you get to OK and hit enter. Now you might have to scroll up a little bit. Okay, here we go. X bar, 24.7. All right, let's start adding this to our list now. X bar, 24.7 grams. We have SX, a standard deviation, 9.2. Variance, we'll come back to that. Minimum 10. Q1 18. We did this all by hand before, and now we find out that the calculator does it all for us. Why didn't I tell you this before? Because you need to know where it comes from. All right, so where do you get the variance? We are in we are in a document here. We're in page 1 of the document. Document 1, page 1. What we're going to do is add a new page. So I'm going to hit Control Add Page, and I'm going to add a calculator. You do not want to go back to your scratch pad. You want to stay right here in this document because all that math that we did on that page 1 is in the memory for this document. If you go to your scratch pad, it's kind of like there's two parts to the calculator. They don't always communicate. So what I'm going to do now is I'm going to pull up a variable. I'm going to hit my variable menu. And you have this long list. You didn't put these variables in, but when you did your calculation, it created this list for you. And we want to get down to SX. Okay, SX. I'm going to hit enter, and I'm going to enter again. Okay, that's the right number. Good. So now I say squared, 84.4. Now, what happens on the Inspire? You could now make another page and put your beef in there if you wanted to. Or you could go back to page 1 and you can now go to the next column and make that your beef column. You can put it all in the same document, but that list of variables will just get longer and longer and longer, and it gets really hard to find the right one. And that is why I always tell people, look at the number first before you square it and make sure you've got the right number. Okay? All right, so back to this. We have standard deviation for chicken is 9.2 grams. So which one had the higher standard deviation? The beef did. Even though this had a right skew, we're talking spread. The span of this data was from 10 to 40. No gaps even. The span of this data was from 8 to 45, with this gap no less. That span and that gap makes this spread higher than this spread, okay? Now, on your calculators, if you look at your list of variables, there are actually two standard deviations. I'm going to pull the 84 back here, and I'm going to go back to my statistics here. And I'm going to go back to my one variable statistics. These two things are actually both standard deviations, SX, and this is lowercase sigma x. So there's 11.3 and there's 10.8. Now, what's the difference? The difference is this one does it like I showed you on the other page, where we divided by n minus 1. You might remember in Algebra 2, we didn't divide by n minus 1. We just divided by the n size. That's the difference. You'll get similar answers, but a little bit different. When you divide by n minus 1, you're dividing by a smaller number, and therefore the answer comes out to be a little bit bigger. The s, you divide by a smaller number, the answer is a little bit bigger. So what's the difference? Well, the difference has to do with whether you're dealing with what we call a sample or a full population of data. So for the most part, in this class, we are going to assume that we're going to be using SX unless otherwise specified. Okay, so these are both standard deviations, but we're going to focus on the SX one. All right, suppose there was an error and the two beef items with 28 were actually supposed to be 38. Would the standard deviation increase, decrease, or stay the same? So beef, we're supposed to take the 28s and we're supposed to make them 38s. So now, do you think the spread, the standard deviation, is going to stay the same, get smaller, or get bigger? Well, beef I did in my 84. So I'm going to go back to my stat menu. I'm going to edit my data. And I'm going to go down and make those 28s 38s. 38, 38. And I'm going to go back, stat, calculate, one variable statistics again. And now my standard deviation would be 12.6. So SXB new is now 12.6 grams. So why did it get higher? Because a standard deviation measures your average distance from the mean. Well, when you put those values in, you just pushed two more values farther from the mean. You closed the gap, but you still pushed values farther from the mean. So you increased the standard deviation. All right, here we go. Interpret the meaning of the standard deviation. So you could go back to the previous page where I said right here, AP phrasing, the typical value of fat content in beef and chicken at McDonald's is an average of, state the value with grams, from the mean value of, okay, so let's just do beef. A typical value of fat content in beef sandwiches at McDonald's will be about, let's go back to the original, the true one, 11.3 grams away from the mean value of, and the mean was 23.1 grams. And you can memorize that phrasing. All you're in general saying is, on average, the fat content in beef sandwiches is about 11.3 grams away from the mean value of 23.1 grams. All right. That's the end of section 1.3. And hopefully you can get your homework done from here.